So what's the plan then? Are we seeing a demonstration?
Oh yeah, I'll present something. I just want to take a couple formalities. I don't even know you guys. I mean, I know you guys, but you don't know me.
That's
True, true.
okay. You can tell us a little bit, and then we'll return the favor.
Well, let me see something. 1 second. This is kind of a new Skype. My Skype gets updated like every 5 minutes.
Yeah, mine does as well.
Yeah, so yeah, I wanted to. Nathan and I was talking more about maybe a presentation, and I wanted to present it to you guys first because I didn't want to go on, Nathan show live, and then come up on a subject that could possibly compromise some of the things that you said before that you hold on to. You understand what I'm saying?
Yeah, no, I hold on to very little. So if you're going to shatter some illusions, brilliant, as far as I'm concerned.
Yeah, but you understand what I'm saying. I didn't want to do that purposely.
Fair enough.
Well, you guys are all fired up. What time is it over there?
11:30 p.m.
11:30 p.m.
What time's it in land of maple syrup?
It's 7:30 here. Yep.
It's 5:30 where I'm at. I can tell you guys are getting a little tired. So let me see.
Well, what I'm gonna do, I'm gonna just go and sit on the other side of the room so I can mainly listen. I'll sound a little bit distant, but I am still here.
Okay. Well, my background is it's a heavy science background, mainly in biochemistry, genetics, and quantum mechanics. And that, and I don't know, Nathan, have you watched? How many shows have you watched? When I was on Cathex's channel.
All of them.
Oh goodness gracious! Then all too well. So I got into flat Earth like 2 years ago, and in the first maybe week, I put all the arguments that I have for the flat Earth are still them same arguments. I haven't changed any of them. In fact, I look at a conversation the other day. I got into it with an astrophysicist, the sort of famous astrophysicist. We were just doing it online. It was a private conversation, and I was just messing around, and I looked at the conversation, and it was like May or June of 2015, and all my arguments are the exact same. I was shocked. Right?
How many arguments have you got?
Well, I used to have about 10 to 15, and I said, you know what? I gotta whittle those things down. And now I just have 4. I just have 4, and they're pretty.
Well, I'm listening. Then go on.
Yeah, but I wasn't gonna present them at first. I wanted to talk a little bit about what science is, because I see a lot of people making mistakes. And it's not only on the baller side; it's on our side with what science is, the terminology used. It's kind of embarrassing. So I wanted to go over that, and I'm sure you guys will recognize most of this stuff. I don't mean to insult your intelligence in any way, but maybe some of these things will clarify things and why and why subjects are going on and on and on and on without any reconciliation, and maybe it'll make sense. So, would you want me to present this?
Sure, but to be honest, do us a favour. Tell us your 4 reasons, but don't explain because we'll know them. But the 4 that you hold on to, what are they?
Oh, but the first one was too easy. In fact, I was on a different another science forum. I had never even heard of flat Earth, right? And somebody was on the forum, and they challenged me, right? They said, so I think you know what you're talking about? I said, yeah. And they said, so can you tell me how you can have a gas pressure without a container? That's all they said.
A gas pressure without what?
Yeah, without a container.
Yeah.
That's all they said, right? And it took me less than 3 seconds because I've spent like the previous 6 or 7 years pummeling astrophysics, cosmology, Einstein, all the Newtonian physics. I've spent all my background, evolution, I spent all my background pummeling those things. So I knew it was all fairy tales. But I never thought about, the flat earth. I never, you know what I mean?
Yeah.
The subject never came up. And I mean, it may have came up here or there, but I never really, gave it much thought. And this one guy, he challenged me. I'll tell you what, I knew it was flat, non-spinning, and domed in less than 3 seconds.
So what are the other ones?
As soon as he said it, I knew. So the first one is the salt flats in
Utah?
in Bolivia.
Oh, yeah, okay.
You see my icon?
Yes.
Yeah, that's it. The salt flats in Bolivia. That's it. That's an easy one because, and in fact, my first two here, it eliminates refraction because it's actually measured less than 1 meter of vertical relief over 9,000 square kilometers, right? So that's an impossibility on a ball.
Because it's got to make that curve back up again somewhere, right?
You got to have vertical drop.
It's the same with the abyssal planes. The abyssal planes is the other argument that I use. But
Yeah.
What are the other two arguments?
I used the Evolved Sea Sparrow missile.
Okay.
Because of its line of sight properties from the target illumination radars.
And your final one?
That's the second one. The third one is the non-spinning with the Coriolis effect.
Yeah.
I used 2 planes, one traveling from Charlotte, North Carolina, one traveling from LA. They're on the same latitude, so they should be traveling at the same, miles per hour.
Yeah.
It's a killer, man. It puts an end to it. None of these arguments have any comebacks or coherent comebacks to them.
Okay.
And the last one is the vacuum of space argument. You can't have, number one, you can't have gas pressure without a container. That is, you can't have gas pressure in an open system.
Yep.
Right? So it's over right there. And then you can't have a vacuum attached to a non-vacuum. It's a second law thermodynamics violation.
Yep.
Stone cold. So, like I said, that was over with those. It's over.
Yeah, there's no escaping entropy, that's for sure. Yeah.
Yeah, exactly.
Yeah.
And that entropy argument, like I said, was the first one that I was challenged with. It took me 3 seconds, man. I already knew it. I already knew that space was a friggin' hoax. All that stuff was nonsense, man. So then I got with I don't know if you know Robert Bassano.
I've heard the name.
That's the principle, yeah. Is it Robert Bassano?
Yeah, Robert Bassano. He was old. Nathan, do you know Robert?
Robert Bassano, of course.
Yeah. See, when I first got in, it was like 3 weeks after I first got in, I wrote a post to Robert, and me and him started doing shows before he decided to leave Letter. And then I went with Cathexis, and we did like 14 episodes on scientism. Have you guys seen any of those besides Nathan? Have you guys watched any of those?
No.
So, and I know you guys know Cathexis. I think.
Sure.
So, and then we finished up those 14 episodes, and then we took a break for a while. Cathexis went off on his own little deal.
Yeah.
So, and more or less, that's about it. Hurrying through it. Now we're all caught up.
I tend to stick to the main 3 points. They can't prove axial rotation, they can't prove gravity, they can't prove curve.
Oh, I could destroy all their arguments. There's not an argument that I can't destroy. None of them. Now, we could start this if you want to go over this.
Yeah.
No, we're going to see your presentation.
Yeah. Let me see how I can share my screen. This has changed somewhat. One
Should
second.
the plus sign down by the mic there. Yeah.
Oh, the plus sign down on the mic. Oh, okay. Thank you. And we could just go through this informally. Can you see this?
Yep.
Everyone's good? And just stop me.
I'm good.
All clear.
Yeah, just stop me if you have any questions on it. I'll go through it more or less informally. So, you know, all these guys right up here, this paleontology, archaeology, all these guys up here, they're pseudoscientists. All
Yep.
Saying is more scientific and all these clowns combined. See, I'm not gonna focus too much on these guys. This is I'm gonna focus on the targets because this is where most of the baloney comes from in our genre, right? The astrophysics, astronomy, and cosmology.
Yep.
So the first six, and what I go into is the scientific method because what is science? Right? It's the scientific method. It's not some people just they give you a whole bunch of reasons and they say, well, and then add science on the end. Well, that's not science. That's just linguistics, right?
Yep.
So the final three masqueraders, astronomy, cosmology, and astrophysics, can't formulate scientific hypotheses. If you can't formulate scientific hypotheses and you don't have any independent variables, it's not science, right? Here's the scientific method right here. You know, I highlighted the four main ones. The other three are more administrative and logistical. So it's real easy. Observe a phenomenon, construct a formal hypothesis, test an experiment, validate and validate a hypothesis. Right? If it doesn't have all those, it's not science. So bare bones, and this is from the University of Rochester Physics Department. It's the same as my four up here. Right?
Yeah.
You guys on it?
I'm on it, yeah. I'm on it.
Good to go, no problems?
No,
Yeah,
we're good.
Okay, so the scientific method obviously distinguishes science from other forms of explanation because it's a requirement for systematic experimentation. If you don't do experiments, it's not science, period. End of story. Right? So, from molecular and quantum mechanics, the final arbiter of truth in science is experiment. From Professor Shankar, the chair of physics at Yale, the only things change in physics is experiments. Everything's based on experiments. That's the only way we change our mind.
Yep.
Then we got Richard Feynman. If it doesn't agree with experiment, it's wrong. In that simple statement, it's the key to science, period. This is one of my favorites. Experiment is the only means of knowledge at our disposal. Everything else is poetry, imagination. That's from Max Planck. So the scientific method requires, obviously, I'm doing this experiment, because I want to pound it into people's minds, right? Experimental verification of hypothetical predictions is absolutely necessary, right? So then you ask the question, what's an experiment? You'd be surprised how many people don't know what this is, right? I mean, it's a term, it has a definition. There has to be characteristics of it that meet what it is, correct?
Yeah, man.
So an experiment has a dependent, independent, and controlled variable. It's from Penn State. So what's an experiment? Well, it's a hypothesis test. So what's a hypothesis? Well, it's your experiment statement. It expresses a testable. This is where it's really important. A scientific hypothesis is and only is a cause and effect relationship question. Right? This is going to become very important here in a minute. So the scientific method is hypothesis driven. One makes an educated guess to explain cause and effect. States scientific hypothesis is a special kind of prediction that forecasts how the independent variable will affect the dependent variable. And I colored these. The reason I did because they're common phrases throughout, right? From physics about hypothesis, it's a prediction of cause and effect. From another one from Penn State talks about predictions independent variables, cause and effect. You see, it's the repeating refrain, right? And here they are: independent variable, dependent variable, cause and effect, and prediction. Those are the common themes throughout all those definitions.
Anthony,
So
can
in
you
an
mute?
experiment,
You're causing all sorts of choppy audio.
am I?
It's Anthony.
Oh, might be because the volume's too high. Hang on.
Okay.
Should be better now. I've turned it down.
You guys good to go?
Yep.
Okay. Like I said, these four terms show up in all these definitions. So in an experiment, independent variable is the variable you have to vary. It has to be something that it's tangible. You have to be able to vary it and manipulate it, right? It's varied and manipulated. Independent variable is changed by the scientist, varied and manipulated. Independent and dependent variables. An independent variable, I just do it's a lot of repetition from different sources. So it's cause and effect. The sine qua non is the quintessential tenet of the scientific method. It's the entire spine of science is cause and effect. The whole scientific method is based on it. From the University of North Carolina, an independent variable is the presumed cause, whereas the dependent variable is the presumed effect. The IV is the antecedent, whereas the DV is the consequence. All right. So this gets to a point. I know it took a long time, guys. Just be patient with me. There's a method to my madness. So question, is the flat earth, or any shape for that matter, a cause and effect how I question, or a what is question?
What is?
It's a what is question, right? Can what is questions be adjudicated by the scientific method?
Yeah.
Nope.
Of course they can.
Nope. This isn't science. That's why I wanted to do this presentation, because of this exact thing. Yeah. Okay. So how can a what is question be put into a cause and effect question?
What is the circumference of the Earth if it's a ball?
What is the circumference of the Earth? That's not a cause and effect question. It's outside of science. That's
Okay, I get your point. I get your point.
Yeah, and I'll have a couple more. I'll have an example down here, and we'll go through an example. So, like I said, this isn't science. Now, what is questions are physical law questions, right? Physical laws describe the what and the is. The cause and effect have no bearing on it. Like the second law of thermodynamics. No one can cause and effect entropy, right? It's a what or an is. Like, why does heat flow from hot to cold always? Well, that's a nonsensical question. No one can answer it. It just does and is, right? So essentially, the physical laws are just descriptions of natural laws. They have nothing to do with science. I know that sounds crazy, man, but it's right.
What you're saying is laws are just laws.
Natural. When somebody says the physical laws or scientific laws is a misnomer, because none of the laws go through the scientific method. They just call them that just by fiat. So, okay. And that's the best example with the second law of thermodynamics, because you can't cause and affect these things. All they can do is describe them. And what they usually do, most of the laws are mathematical in nature. And math can only, we're going to get into this, math can only describe, it can't explain anything, right? So what we got here on both, I thought you guys might like this. I wanted to break it up, put some visuals in there. So what we got here on both sides by the truckloads is this. So Elmer Fudd thinking they're Richard Feynman's. So let's talk about scientific. This runs rampant throughout, this genre. People talk about scientific predictions. Well, scientific predictions are the result of scientific hypotheses, independent and dependent variable relationships. Right here from Colorado State. Scientific hypothesis is a special kind of prediction that forecasts how the independent variable will affect the dependent variable. So my question is, can you have a scientific prediction without a viable dependent and independent variable? No. There's quite a large chasm between Gene Dixon, Edgar Casey, Nostradamus, Carnival Tent, and cyclic repeat dictions, right? Those aren't scientific predictions. Even from the Elmer Fudd reference library and wiki, in everyday speech, theory can imply that something is unsubstantiated or a speculative guess. The opposite of its meaning in science. To say these different usages are comparable to the opposing usages of predictions in science versus everyday speech. So you guys know, there's a typical one. We can predict eclipses. And usually I say, okay, what's your scientific hypothesis and independent variable? And, I usually get this response, drink bleach, flat tard, something like that. This isn't a scientific prediction. See, this is tantamount to watching a clock for 300 years. Then at midnight of the first day of the 301st year, the diviner predicts that in the next 4 hours, the hour hand will land on 3. See what I mean? It's not a prediction. Here, I'll give you another one. After watching Super Bowls every year for 40 years, I predict that next year in late January or February that a Super Bowl will be played in a stadium with the over-under not exceeding 80. Is that a scientific prediction? No, it's a cyclic repeat. I'm just watching cyclic repeats. Watching recurring patterns and regularity, then pontificating is not a scientific prediction. Lunar and solar eclipses predicted by the Babylonians at 800 BC, right? I'm pretty sure that the Babylonians and Mayans didn't have a heliocentric spinning ball model, right? All they did was watch the recurring patterns and regularities. That's all they did. It's not a scientific prediction. It's not a scientific prediction whatsoever, right? Because scientific predictions have to be hypotheses. You have to have something that you're manipulating. What can anyone manipulate the sky? No. Here's another big problem, and this is why I wanted to really stop here before I presented this on your channel, because this term right here is a big problem. You guys still with me?
Yeah, man.
I know I'm speaking fast. If I'm going too fast, you can just tell me to slow down. Okay, here's a contentious issue, right? Models. See, a scientific model is used in situations when the hypothesis has a limitation on its validity. This is pseudoscience because there's no such animal as a scientific hypothesis with limited validity. It's tantamount to a woman being a little pregnant. See, real scientific hypotheses are either confirmed or invalidated by experiment, period. End of story. They don't exist in perpetuity or wait for more data. A model is conjured when the alleged hypothesis is untestable. That means there never was a scientific hypothesis to begin with, right? So airplane models and those types of things, those aren't scientific models. Maps, projections aren't scientific models. Mathematics doesn't and never produces scientific models. Never, ever.
No, it's painting by numbers, isn't it?
Yeah, see, you can't, like when people say, the normal thing is that people say models can predict. No, they can't, because you don't have any independent variables. They don't predict like a map projection. Like, I could put a map of the United States down, go to Pittsburgh, and then I can say, well, I predict if I go west, I'm going to hit into Columbus, Ohio. That's not a scientific prediction. I already know Columbus, Ohio's over there. Right? You guys see where I'm going with this?
Yeah.
Yeah, I see what you're saying.
Yeah, see, the problem is when people say model, they're not scientific models. And this breeds all kind of confusion because people say, well, what's this? What's your model? What's their model? It doesn't matter. It's pseudoscience. Now, I'm not taking away anything from you guys. When you projected, when Chris projected, his flat with, without a useful, better term, the flat model, that's not a scientific model, is what I'm trying to say. It's just a graphic representation of something.
Cuts deep, man. It cuts deep.
It's see, I didn't, but I don't want to cause any. I'm not here to get any fights or anything, man. You see why I wanted to do this, because if I go on your show and start going over this, and then you guys still continue with the models thing, you see where the contradiction lies, or you guys don't mind it.
Well, to be honest, if they're going to state that refraction can bend light back from behind the curve of the Earth,
we're going to get the refraction. We're going to get the refraction here in a second. You want me to just continue?
Yeah.
You guys are yawning and tired. Nathan's are. Oh yeah. I got you, man. I know you. I know it's late. Okay, math. Okay, math isn't science or physics, much like a tape measure isn't carpentry. One of the main reasons is they're different words. And then we could go to Professor Black Reasoning he's a professor of physics. That's the whole point about physics, is not mathematics, right? Because we already went over what science was. That's anything. Physics is basically all of science, because when you boil right down to it, genetics, quantum mechanics, obvious is physics, biochemistry, all fall under physics when you boil them right down, right? So maths don't prove reality. I know I'm preaching to the choir here, and I'll give an example. 1 apple minus 6 apples is -5 apples, right? That's a mathematical proof, right? Well, show me -5 apples, right?
Show me 7/6 for the standard refraction calculator.
We're going to get there. Give me a minute. So, and then my next one, I say, okay, well, you think math science, give us the equation for germ theory, right? That's ridiculous. That'll never happen. So math is immaterial. It's abstract. It's domain specific, and at best, it merely describes. It doesn't explain anything, squat, nothing.
It definitely doesn't prove anything either.
Exactly. Conversely, actual scientists are in the business of explaining. See, there's the juxtaposition. You got descriptions versus explanations. Descriptions, like the physical laws, and explanations, scientific theories, real ones. So, and the real ones are cause and effect relationships, because scientific theories result from validated hypotheses. So any theory, it better have experiments, and they're all cause and effect. And I say, can you show one case in all of history where mathematics caused any phenomena? Can you show how the laws of motion caused the billiard ball to roll across the table? You see how insane that sounds?
Yep, absolutely.
Here's another important point: explanations. Any moron could give an explanation.
Yep.
Watch. A friend discovers large burned scorch marks on his garage walls. His explanation: invisible fire-breathing dragons exist. What's wrong? It matches the observations, right? The key is, can you scientifically validate the explanation by experiment? That's the key. You got to answer all these questions. What phenomena was observed? You got to post a formal scientific hypothesis. None of these guys from the spinning ball religion, and I've dealt with all of them, they can't even post a simple scientific hypothesis. I've been doing this for about 12 years. I challenge PhDs. They can't even do it. They can't post a formal scientific hypothesis. It's just simple cause and effect. So if you can't validate your explanation, then all you have is a just so story. Anyone can do that. I just did it right. My buddy just did it up here with invisible fire-breathing dragons exist. If they do, it's just a just a story explanation, or they challenge you to give an explanation. Well, they're just so stories. They're arguments from complete ignorance, and they can't be disproved. It's the acme of foolishness to even consider, much less attempt to disprove complete arguments from ignorance. I usually ask them, do you find it scientific or logical to imagine things, then have other people attempt to disprove your imagining before you give evidence of your imagining? The appeal is tantamount to claiming that dark matter is created by invisible three-toed gnomes throwing pixie dust in a black hole behind a crab nebula, then requesting others disprove it, or your theory is true. Right? That's idiotic. You have to scientifically validate your claims first. Here's a similar train wreck, right? Stars spin in opposite directions in the north and southern latitudes, right? How many times have we heard that?
Yeah, plenty.
Yeah. Well, their explanation is, we live on a spinning ball. Matches the observations, right? Well, the conclusions from mere observations, looking at something, are solely drawn from inference. They're just educated guesses at best. But conclusions from experiments are solely drawn from practical demonstrations of cause and effect relationships. Can you do anything with the stars? Can anyone manipulate them physically? No. There's no independent variable. This isn't science. This is fairy tale land. Right? And by the way, this is mind-numbing juvenile short bus parlor trick. Why? Because what direction, north, south, east, or west, are the stars spinning in the northern hemisphere? Right? And what are they spinning in the southern hemisphere? They're all spinning from east to west. It just depends on your position, correct?
Sure.
Yeah.
Right. If you're standing in between two carousels and both are spinning from east to west, and you look at the northern carousel, it's spinning from your right to left. That's counterclockwise. You then turn around and look at the southern carousel, it's spinning from your left to right, right? That's clockwise. You then look at Dopey the Clown, and now these carousels are spinning in opposite directions. No, they're not. You just changed your reference point, right? You guys with me, or am I going too fast?
I'm with you. I'm just wrapping my head around it conceptually.
Right? If you stand in between two carousels and they're both spinning the same direction, if you face north and look at the northern carousel, it's going to be spinning from your right to left. But if you do an about face and look south, it's going to be spinning clockwise. But they're all spinning from east to west. Follow?
Yeah, no, it depends on your frame of reference. Yeah, absolutely. Carry on.
I put a little, then Dope the Clown hires you on the spot, because second graders are going to start throwing their cotton candy at you. You say that out loud.
Yeah.
Okay, here's another one. You guys know this. Science says. Well, science isn't an entity or a result. It's a method, the scientific method. Methods don't say, run, jump, swim, point to, do the hokey pokey, or anything else. It takes sentience, precious intelligence to do that, to be alive. Additionally, to say something, it requires vocal cords, tongues, lips, lungs, or typing skills. Science isn't alive or have any biological anatomy, ergo, it's a reification fallacy. Okay, you guys follow this one? This happens constantly, right?
Okay, reification fallacy.
Yeah, it's a reification fallacy. What do they call it? It's when you impugn physical attributes to non-physical concepts.
Okay.
Like the stars being a real thing.
Yeah, they have another name for it. It's a reification fallacy. There's another name for it. It loses me right now.
Okay.
Okay, now you guys' favorite. Okay. This drives me nuts whenever I hear this brought up. I mean, I'm pulling my hair out. Okay, see if you could follow me on this. You're going to say, oh man, atmospheric or terrestrial refraction. Okay, let's take a look at what begging the question fallacies are. Okay, begging the question fallacy happens when you use one of your premises, but the premises include the claim that the conclusion is true, or directly or indirectly assume that the conclusion is true. You guys got that?
Yep.
Yeah, circular references. Yep.
Yeah, it's more or less circular reasoning. So what's the baller's overall conclusion, right? Because the Earth is a sphere, correct? That's their conclusion of every single argument they have, correct?
Yeah.
Yep.
What do they use? What do they use as one of their premises to prove that conclusion, right? Atmospheric or terrestrial refraction. Well, that's a stone cold begging the question fallacy. Why? Does light refract? Answer, yeah. Is that the same and can be accounted for by terrestrial refraction? Answer, nope. Key word is terrestrial. Why? Because terrestrial refraction already assumes a sphere. It already assumes it in the calculations. The calculations assume the radius of the Earth. And this is from San Diego State. The atmosphere is also curved as it follows the shape of the Earth. In the calculations below, we adopt the rough value of 6,400 kilometers as the radius of curvature to make the calculation simple.
Hey,
See
sounds familiar.
It's begging the question. They're assuming the very thing they're attempting to prove. It's over.
Which means the light travels in curved lines and not straight lines. Yeah, that's the reference. Yeah. Which is false, right?
Well, no, it's not only that it's false, the reasoning behind it is fallacious.
Self-reference,
they can't use it because the calculations already assume it. You guys follow me with this?
Sure.
Yeah.
Seen it in practical application when they've modelled this stuff.
See, then we go back there, and I always go back when they say model. I go, model? They get pretty upset at me, but I mean, I'm just trying to let them know that they're all screwed up. So this terrestrial refraction, you guys know when they go to do their calculations, what's in their calculation?
An arc.
The radius.
6R.
The radius, correct?
Yeah.
Correct.
But wait a second. We're saying they're trying to prove the curvature. They can't use this. It's circular. This is circular argument. Anytime they use refraction, and like you said, Nathan, earlier today, you don't deny refraction. No one does because we all see it, right? But when they use refraction in their arguments, they're using terrestrial refraction, and they're trying to pinpoint it to explain why they're living on a sphere, but the calculations already assume it. Begging the question. It's textbook. Now, you come out saying this, they're going to get upset at you, but there's no way out. There's no way out from this. It's stone cold. It's over. It's over from the beginning. So what they have to do before appealing to terrestrial refraction, they have to scientifically validate the radius of the Earth. They have to answer these questions. And obviously they can't do it because these are cause and effect questions. The radius of the Earth is a what is question. So that's why I said it'd be easier resurrecting Alexander the Great's horse. That's it. And then obviously I just told you about my proofs down here. I figured this would be quite long, and I didn't know whether you wanted me to go into these proofs, Nathan, or not.
Yeah, man, if you want to go through them again in detail while they're on screen.
They're not too big. Can you guys even see these things?
Yeah.
Yeah, so and I put my pieces of flair into it. So according to the heliocentric sun-worshipping spinning ball religion, every point along a tangent in every direction from your feet drops. So it's vertical drop, and it drops away from you at 8 inches per mile squared. You guys obviously know that. So from Oxford Journals, we have the Salar del Uyuni in Bolivian Andes. It is the largest salt flat on Earth. It exhibits less than 1 meter vertical relief over an area of 9,000 square kilometers. See, this is done through satellite. You know, they're balloon satellites or high up. They call them satellites, but we all know what they are, right? So this proof takes refraction, that begging the question fallacy, out of the equation to begin with, because this isn't based on refraction. This is based on actual measurements. So it's a contradiction. You can, this is a geometrical flat plane. You can have a myriad of topographical features on a sphere, you know, mountains, ridges, saddles, spurs, depressions. But you know what you can't have? You can't have a geometrical flat plane on a sphere. Can't do it. It's a married bachelor.
Yeah, I totally agree. It's a contradiction in terms. It'd be a flat spot, visible
Might
from
want to
space.
consider adding the Nile River to that little spot there in your presentation. Right, it's a good one because it's only like 3,000 feet of drop and 4,000 miles or something crazy. Right?
Yeah, right. Yeah, but this one's too easy. This one limits it. I don't have to go. This is hard enough. Guess what the number one comeback is for this argument? Take a wild guess.
I don't know, gravity. I'm not sure what they come back with.
Too big to see the curve. Some complete nonsense.
Satellites. Because this information was gathered by satellites. They say, well, it's gotten by satellites and you don't believe them. I say, well, that's not my argument to begin with, number one, because how the data was gathered has nothing to do with what the data is. And of course, we already know they were making topographical maps long before satellites. Anyway.
All right, what's vertical relief? Does it just mean like drain off? Is that what it means?
Vertical relief is the same thing. It has to be vertical drop on a sphere. That means elevate. You have to have a vertical drop. That's that 8 inches per mile squared. That's what we talk about all the time anyway, the drop, right?
Sure. So it's just a 1 meter drop in that surface area, 9,000 kilometers squared.
Less than 1 meter. So that's I calculated it. What is it supposed to be? Did I have it here? It's like 780 feet. Or no, I'm sorry, 780 meters. If it was a ball, that's what it should read, 780 meters. This has less than 1 meter over the entire thing.
Yeah, it's like a mirror.
Yeah. So this kills it right there. I don't really have to go. It's over. I usually stop right there with most people because once I bring up, oh, wait a second. I have it. It shows in fact, this one even shows it. I don't know if you guys can see this. Maybe you can. From the study itself. I'll show you where they measure it. That one. Which figure is it? I probably passed it by. Here, right here. You guys see this one?
Yep, clear as crystal.
Yep.
Yeah. So from the northern section down to the south is 100 kilometers. Well, just go in there any curve calculator, and it's going to be like 760 meters of drop.
So what's
if you're on a sphere?
What's SRTM?
Where are you looking at?
It says at the bottom. Right, there you go.
SRTM photography. Did they define that somewhere? Let me see. I'd have to search for it, Nathan.
You gave a brief description. I just saw it as you were scrolling through.
Did you see it somewhere right here?
Here we go.
I don't
think
see
it stands for scalar reveal topological mapping, I think. Yeah.
Ah, okay.
Bob on.
Mhm.
Excellent.
Yeah,
Okay.
so this is over right here. There should be 760 meters of drop. There's only one, right? It's over. Over, what, right there. And I don't know if you guys ever heard of this one, the Evolved Sea Sparrow missile.
It rings a
Was the
bell.
line of sight for 23 kilometers or something on those things?
You have to have the target illumination radar shoot out a 2-degree pencil beam, RF pencil beam. They must have line of sight to the target.
Yeah, within 23 kilometers or whatever. Yeah.
No, its range is more than 35 miles.
Oh, was it that far? Yeah.
Yeah.
I knew they were a long ways. Yeah.
Yeah. It's, in fact, the maximum effective range is classified.
Yeah, it's probably
Yeah, I
more like
remember
100 miles.
Jeff
Yeah.
Stewart going through the Aegis targeting system, and I'm sure this missile's attached to that. And yeah, he was
No, this has a separate targeting system. This has to be on the ship with their target illumination radars. It can't be from any other position. You know, like somebody off on another ship. The missile fires from the same ship that the missile was fired from. It has to be until 2020.
Yeah.
Okay.
Yeah, they paint the target. They paint the target from a big laser on the ship, on the horizon or wherever, and then they fire the missile, and it tracks to that point.
Yeah.
And by paint the target, you literally mean direct line of sight. They put a dot on that target.
Yeah, a red dot is on the target. Yeah, and it triangulates back to the ship using the coordinates between the 2 points. Yeah. Yeah, it's pretty crazy stuff. Yeah.
Yeah, very cool.
And I chose this missile just because of the line of sight requirements, right? It takes out refraction. There's no way to get out of this. So they have to explain how a 2-inch RF pencil beam can penetrate 385 feet or 117 meters of target hidden height through a wall of water 24 miles in length. That's impossible. RF doesn't penetrate water. Either the Evolved Sea Sparrow Block 1 exists or the spinning ball religion exists. Both can't be true. So this non-spinning, see, the Coriolis effect, no one understands what the dang Coriolis effect, at least of all ballers, right? They have no clue.
I'd like to think I've got a pretty good idea. I don't know. I think I've got a pretty good handle on the fallacy that is the Coriolis effect by now. Although you did qualify that by saying most ballers, so I'll shut up.
Yes. I didn't mean you guys. I'm saying most ballers, they couldn't, if you say define the Coriolis effect, what they'll say is most people will say toilets draining in opposite directions or storm spinning, right? They have no clue what it even is. And most of them use it as a cause. But the Coriolis is an effect. It's not a cause. So,
an unproven effect, yeah.
Well, it is proven. Now, listen, this is proven. It's proved, but it's not proven on the Earth. But it is proven on a merry-go-round, right?
Yeah, that's yeah. But I mean, as a relationship to the Earth itself, it's never been observed. Yeah.
Exactly. This is what my argument details. You got it. So let's go from the top. For the Coriolis effect to exist, you have to have necessary conditions, right? And there's two of them. You need two differing frames of reference. One rotating, that's a non-inertial, that's the Earth, and one rotating and one non-rotating, that's the inertial, and that's the atmosphere. Here's the Coriolis effect. Here's the definition from Seagard Douglas, and this is a college level textbook. When set in motion, freely moving objects, including air and water masses, that's clouds and vapor, move in straight paths while the Earth continues to rotate independently. Because freely moving objects are not carried with the Earth as it rotates, they are subject to an apparent deflection called the Coriolis effect. It's an apparent deflection. It doesn't actually deflect. It's just apparent. You guys following this? Oh, I forgot to tell you, I'm retired military.
Yeah, except for airplanes, bumblebees, wasps,
Yeah, yeah. The list goes
seagulls and
on.
bird shit and everything else. Yeah.
Yeah. Well, I forgot to tell you guys that I was retired military. I spent half my career in reconnaissance, and guess who was right down the hall from me for about 5 years?
Go on. Who?
Snipers,
Snipers.
Yeah. Yeah.
the sniper platoon, and I used to
Yeah.
cross train with these guys. Right?
I got a friend. I got a friend
I-
that's former FBI sniper too. Yeah.
Yeah. I personally made shots with Russian sniper weapons at 1,500 meters out. Let me tell you something. The sniper, and we used to talk smack constantly. The Coriolis effect was never even mentioned, much less actualized. Right?
Unless your name's Jason Bourne.
Yeah. So I love it when these guys bring up military because I'm retired military. They're through. So my argument basically is, and it's a long argument, but it's a simple argument. See, the object in question, let me just roll past that. So if the Coriolis effect exists, and like I said, I put with respect to the Earth, then a flight from Charlotte, North Carolina, nonstop, traveling at 500 miles an hour, with both locations on the 35th degree north latitude, that means they're both allegedly spinning at 860 miles an hour, should be 1.5 hours, but it takes 4.5 hours. And I did the airspeed and the ground speeds. So I say in my example, two different frames of reference, one, the Earth and the atmosphere and everything in it. In other words, based on the law of non-contradiction, the Coriolis effect with respect to the Earth and the Charlotte flight at 1.5 hours are either both true or both false. And the flight is most assuredly false. So in conclusion, the Earth's not spinning. The ball goes by the way of the dodo bird, or you're a stationary ball geocentrist. It's over. So what do they usually come back with, right? The atmosphere spins with the Earth, but that can't be true. Because if it was true, you wouldn't have the Coriolis effect.
Yeah, precisely. It's a contradiction in terms again.
Yeah,
You can't have bullets curving because the Earth's curving underneath it and have the atmosphere trapped and dragged along with it as well. It's a pure contradiction.
I got Rumpus into a discussion one day. I got him to admit that air is not atmosphere.
Okay.
I'm going to tell you right now, watch this one. It was so good, I had the screen capture it. Hold on a second.
Cool.
You're going to love this.
I like these little moments from comments. Sly Sparkane's especially good at them.
Let's see if you can see this one. I'll
Yeah,
go
I can
ahead and
see it.
expand it. Can you see it?
Yeah, it starts with you and utter moron.
Oh, you've only got two udders. You got to do better because you need like 4 udders, and then you're really getting on his nerves.
I've hammered this guy so many times. It's unbelievable. Look at what he says down here, brothers.
Capitalized not as well.
Air is not atmosphere. I'll tell you what, I've gotten so many discussions with this idiot. In fact, I had a debate with him one time, man. It was bad, dude. It got real bad. He's a moron, this guy.
He's a dishonest prick.
My 12-year-old daughter knows more about science than he ever will. Just to let you, you're going to like this one since I got this up. Because you were talking with Negator the other day, right?
Yeah.
Okay, let's see what he has to say.
I use the Coriolis effect. I use the Coriolis effect occasionally, and I'm trying to describe stuff to people too, like because I come from a construction background and major projects and whatnot, right? And I've never seen a tank, like a 1,000,000-gallon tank in the northern hemisphere, designed to turn clockwise, and the one in the south to go anti-clockwise because it'd be more efficient, right?
Yeah,
because the extra torque and heat on the bearings and the motors to turn the water and everything else. And the pumps, we pump everything in one direction in the south and in another direction in the north, and you never engineer anything that way, right?
Right.
It's garbage.
Right. Okay, this one you're gonna like this one. Look at the last two sentences from Negator. He says that because we got into a discussion about the atmosphere and, my vacuum of space. Look what he says here. He says that's like saying 0.0000 all the way down to 3 millimeters is massively different than 1 millimeter. He says this is a minuscule difference. If you go about 6 more zeros on here, you're down to the Planck length.
I was going to say, how many zeros is that? Like negative 10 or more? 20?
Negative 20, 22 zeros right here.
Yeah, negative 20, 23 is the Planck length. Yeah, exactly. Yeah.
Nathan, can you appreciate this, man?
Yeah, I see what you're saying. It's not a minuscule difference.
This guy would get laughed out of a 3rd grade math class by security on his way to Shady Meadows. This is ridiculousness. Sorry, I just had to show you those guys. I couldn't help myself. It's very moronic. So back to so let's wrap the Coriolis effect. See, the only way they can come back is the atmosphere spins in lockstep with the Earth. Well, number one, like I already said, then there'd be no Coriolis effect. Number two, they have to show the experiment where gases rotate in lockstep with a rotating solid body just 5 centimeters above the surface. Right? Because gases don't do that. There's space in between gases. There's no intermolecular bonds, right? And this is my best one. This is the best one. Please explain east, north, and south surface winds. Right? You can't have the atmosphere spinning with the Earth from west to east and have east, north, and south surface winds. It's a contradiction. See it?
Yep.
And of course, we not only have those, you have different wind speeds moving at different directions simultaneously at different elevations of the atmosphere, all the while the atmosphere is continuously spinning east in unison. That's a contradiction.
Well, every tree, plant, and blade of grass in the north would point one way, and the ones in the south would be the opposite, right?
So I say these are contradictory statements, right? Yeah. Which do you think is false? And moreover, every cubic nanometer as you go up in the atmosphere would have to travel faster, right?
Yep.
So they must have differing tangential speeds. Every cubic nanometer of atmosphere rising in elevation from each respective horizontal cubic nanometer atmosphere, they must have different tangential speeds.
They'd be following the inverse square law too. It'd be exponential growth, right?
Yeah, it's friggin' moronic. I mean, and how far does the fairy tale increasing speed rope-a-dope fairy tale spinning atmosphere end? How far does it go up and where does it end? Because you'd have guillotine wind shear at some point, wouldn't you?
Pretty much, yeah.
At some point, there will be no air and air. You got to have that. There's got to be some transition point. So
the friction, but there'd be some point where there'd be so much friction, you'd end up looking like you'd be like staring a plasma torch in the face.
Exactly. Right? I had that in here and I took it out. I had it in there in my original argument. You're exactly right. Yeah. And then I asked him how are the gas molecules attached to each other? Glue, Velcro, pixie dust, something other. And where are you getting the energy from? Because you have to have increasing amounts of energy or shot in the arm injections to keep every cubic nanometer of atmosphere, all of them in tow. They would have to be continuously injecting energy into it. It's fairy tale, man. So in this is the last one, man. We'll wrap it up. So, and then I ask him, there's no vacuum of space. This is the big question right here. This stump cathexis used to love this. How do you have gas pressure, atmospheric pressure, without a container to begin with? Because the definition of gas pressure is the pressure of the gas is the force the gas exerts on the walls of its container. I have propane. My house runs off propane, and I have a tank in my backyard. I always catch those guys, filling it up. I just mosey on out there, right? I say, "Hey, what's up, man?" I say, I got a question for you guys. I say, "You're putting propane in my tank, right?" And they go, "Yeah, of course." I say, "You know what? Can you have gas pressure without a container?" And they go, "No, of course not." So I say, there's 13 pounds per square inch of pressure hitting you, gas pressure right now? They say, "Yeah." Guess what I do? Look up and ask,
yeah. Where's the walls? Yeah.
Where's the container?
Don't they normally reel off some mumbo jumbo about pressure gradients?
Say again?
They normally rattle off something about pressure gradients. I can't remember the exact baller argument.
Yeah, Nathan, you're exactly right. But guess what? They're begging the question because before they can discuss pressure gradients, you have to explain gas pressure first. You can't have gas pressure gradients without gas pressure.
Yeah, they try to claim gravity is what keeps the molecules attracted to the ground, and then there's a differential between that and the vacuum of space, and blah 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 blah, and they go on and on and on. Right?
I got their huckleberry for gravity. First of all, gravity doesn't work and I'm going to tell you right now, because you can have a bicycle tire. What happens when you press the valve stem on a bicycle tire?
They'll all equalize.
Yeah, it increases entropy, right? It escapes, but you can't get any closer to gravity than that bike tire.
Yeah, well, high pressure always goes low pressure no matter what.
Yeah. That's second law. That's entropy law.
Yeah.
So they're stuck right here. And you see, hey, I heard you, Nathan. You go, I can't commit to that dome. You have to commit to it, brother. You know why?
I know. I'm getting there.
People always come up and ask me. They say, "I need physical proof of a dome." I say, "You got air pressure, right?" They say, "Yeah." I said, it's the same argument. I could say the same thing about ribeye steaks. I know, as long as I have the premise that ribeye steaks come from cows, if I have a ribeye, the cow must exist, whether I observe them or not. See where I'm headed with that?
Yeah.
I still kind of err towards the electrostatic exclusion zone, right? It doesn't necessarily mean that the dome is necessarily solid. Right? There are other explanations, but it's so far beyond, some, modern physics that they wouldn't accept it as a thesis anyway. But
who wouldn't accept it?
Well, you'd have to really do some studying on it to prove it, like the exclusion zone. When you have like hydrophilic surfaces in water and whatnot, you get a negative charge and a positive charge differential, right? You create that layer of exclusion, right? The same applies to gases too, right? So there is potential that there could be a superfluid above here that's containing the gases below, right? It's not actually solid, but it could be a superfluid or a plasma state or an electromagnetic plasma state, right? We can't see it because it's transparent, some kind of pressurized gas that's denser than air, right? Being held aloft by negative charge.
I'd have to see that because that goes against my definition of gas pressure, brother.
Yeah. Yeah. If you have like, you can have like a denser gas and then put a lighter gas inside it, right? And have it hold it as a bubble, right? So we could be in a bubble inside something else.
Yeah, but it has to be a physical barrier.
Oh yeah, there is a physical barrier. Yeah, absolutely. Yeah. Not necessarily solid though. That's all I'm saying. It could be a gaseous or a superfluid state, right? Highly conductive.
Yeah, you know what? I went through this discussion with Robert Bassano. He was all about this superfluid helium, right?
Right.
Yeah. Yeah, there's a lot of problems with that. But we don't have to go that road. It's a second law of thermodynamics violation anyway, obviously, right here. Yeah. You can't have a vacuum attached to a non-vacuum. You can't. It's nonsense.
That is true. Yeah, absolutely.
I'm
with you there. I agree.
Yeah. And in fact, I ended up and that just crushes space into the incoherent oblivion. I mean, And I have this
Well,
quote.
they'd have to back that up with an experiment, right? Put a ball inside a vacuum container and have a gas stick to the surface or a fluid stick to the surface, and then pull a vacuum on it, right? And I want to see that experiment without the water freezing or the gas being diffused into the surrounding vacuum, right? Entropy,
Yeah, that's it.
right?
Yeah, you're never going to see. It's a slap in the face, second law violation.
Yeah.
So that ends it up. I know it's real late for you, Nathan, and I don't know where Riley went. He's probably sleeping.
No, yeah, I'm just nodding off.
I don't usually bore people, man.
No, you're not
It's
boring
been a
in the
long day,
slightest.
man.
That was
I was
ace.
up
I
early
really
this
enjoyed
morning.
that. That was ace.
It was good, yeah. Yeah,
So-
if you're going to, I would just suggest if you're going to present this exact layout here on Nathan's show, maybe just add a few more pictures, like when you took us to the website there and showed us the picture of the lake that's flat and whatnot. Maybe grab some pictures if you don't get into copyright problems, and then just share them. Right?
Yeah, because
There is one bit that's missing though.
All right, guys.
The core of the Earth.
Curie temperatures, yeah.
Oh,
Yeah,
I already got that, brother. Didn't you see my post on that before?
No, go on. Show us again.
Oh, I didn't show it in this presentation.
Because
Hold on 1 second.
the iron core's an issue.
Yeah, I have a whole spill on that. 1 second.
Yeah.
I even posted it. I thought you guys seen that post, but maybe you didn't. Hold on a second. I'm pretty particular or specific with it. Oh, here it is. I don't know. This is kind of small too. I don't know. Hold on a second. Let me take this off of here, and I'll just expand.
Yeah, I always like to pick on that one too, because it's not a self-sustaining electromagnetic dynamo, right? That theory is completely bonkers, right?
Right. That's ridiculous stuff, right there.
If it were true, we'd have perpetual motion machines everywhere. Throw one in your car and away you go. Right?
Exactly. Here, let me put it right here, and I'll go ahead and make it a little bigger. Kind of small. Get up here. Can you guys see that?
Yep.
There you go. Yeah.
Yep.
So, and now we started off with, according to the heliocentric sun-worshipping spinning ball religion, the Earth's magnetic field is caused by the Earth's outer core. That's a liquid nickel iron alloy.
Yep.
So the Curie point, the temperature at which elements lose their magnetic properties, you guys already know this. Then a discussion of the Curie temperature is an essential temperature for a ferromagnetic material. For example, a ferromagnetic material has a temperature under its Curie point. Then the material has a net spontaneous magnetization. So anything over its Curie temperature, then the material becomes paramagnetic or does not become a magnet. So the melting point of iron, and that's wrought, is 1482 to 1593 degrees centigrade. The melting point of nickel is 1453 centigrade. The Curie point of iron is 1043 Kelvin or 769 centigrade. And the Curie point of nickel is 627 Kelvin or 353. It's over.
Yeah.
It's over right there.
Yeah, and then they reverse the solid versus liquid phase too, right? The liquid would actually be in the middle and the solid more towards the outside, right? They actually got that upside down.
Yeah. Yep. And that Curie temperature is 8 times past it.
Yep.
Oh, yeah.
So that's preposterous. I noticed you guys talking to about one of your shows, and somebody, I think it was that knucklehead Nick without the L.
That was Paul Voigt that Anthony had on the ropes.
Paul Voigt. Yeah.
Yeah, we keep trying to hammer Paul Voigt with that one, right? Because there's no answer to it. We know it, right? So it's like, yeah.
So, I can go into about 65 different subjects, but I wanted to limit it to just those that I presented.
Cool. Absolutely ace. Thank you very much.
Yep. It's good.
Don't